So we're dfuse. We're building blockchain APIs, slick blockchain APIs. Okay, that's what dfuse does. And so dfuse is run by a few serial entrepreneurs here in Canada, people who have built and sold a few businesses, who know the ropes of building solid, technology businesses. And in the last 2 years, we've been working, especially in the blockchain space, and building data tools and data access tools. We design all of our systems, and we want to achieve this for our customers. We want a great user experience, and customers that come to our platform have recently told us that they were able to shrink their code base by 90%, 75 to 90%, because we do a lot of things on our side. Maybe some of are newer to the blockchain will eventually discover that there are complexities in querying a blockchain because it moves all the time, and there are irregularities in the view of the network that you see, depending which node you query, right? There's some eventually consistency. So things get resolved as time goes. If your application is sensitive to real-timeness, you want to have the information fast, but be able to readjust in case there are some things like reorganizations. And so we designed all of our system to make it extremely simple, and to have the API do all the work for you of navigating all the intricacies and failure conditions and network conditions for you, so that you listen on one single stream that is extremely reliable, that can sustain disconnections, and even though you're offline for some time, you can get back on. And our tagline is, we never miss a beat, right? We'll guarantee to never miss a beat with our API. We've designed all of our system also to be ultra low latency. Some other feedback we got from the Ethereum stack is that some of the competitors, hi there, some of the competitors will send you block information 1 to 2 seconds later, not just a few milliseconds, but the API, the dfuse API, will give you the information from the chain faster. So that's very important for building trading algorithms or things that will manipulate tokens on the chain and take decisions. And so we also provide one unified view. Some people I've heard so they try to use something like Infura, and they query the different nodes over there. But it happens that if your load balances to one node or the other, and from time to time, well, you'll actually hit this node, which is one block further, and this one is one block later, and they're not at the same level. So you query a balance, but it has changed between those two blocks. So it's difficult to get a coherent view of what's really on the chain right now, right? Or even like that was in the past, and maybe the past is the new truth, because this one has not been updated with your organization. Is all that fuzziness, it's difficult to work with when nodes are load balanced. On dfuse, you have one platform view. So if we send you information, we send it faster, it is because the whole platform knows about it. And if you connect to another node after this connection, it'll navigate you through the same state, right? It's when it locks them. If we show you some reorganization, we'll always show you, we'll always allow you to navigate your way out of it. Otherwise, we might not show you some reorgs because some blocks are mined and just were propagated just a small part of the network. In that case, we'll never show it. So we designed our system, you'll see, with cursors and things to allow, like what you would expect, like when you're querying, I don't know, MySQL or some other databases, you give it a cursor and you have sort of the isolation and execution, right? If you query our system for search, for example, we're going through the different products after, but through search, if you dropped, you can bring back a cursor and it will navigate exactly where it left off. Whereas sometimes with blockchains, you query and then it happens that the node over there skipped one block as it went fast or whatever, network condition, and then you miss some information in between. That's annoying. Unless you do on your side a lot of code to fetch always, for example, the 3 last blocks and have some retry mechanism to make sure that eventually you get all the data. That's probabilistic, right? That's not something, as a developer, I would be comfortable rolling out my stack on, and otherwise it puts complexity on the developer's side. So we try to, remove complexity from the developer's side so that they can concentrate on building something cool in their contract, you know, as a community. I invite you all to go to ethq.app, okay? Look, I'm gonna share my screen here, and so this is ethq.app, and this is a block explorer, you could say, but our goal with that is not to make it a general purpose block explorer where you can see your token value and market capitalization. This is about data, and you'll notice here that this block explorer has a view that no other block explorer has because it leverages the diffuse data. And all of these things, you know, a goal is for you to easily get those queries in. That's a GraphQL query here that was used to feed this page. And the goal is always to bring it back to a programmatic access. And you'll notice a little small +9 here. So this transaction here has an internal transaction. And these elements are not visible on other explorers, but this is also all available. So this is, let's say you call someone's contract here, and then this contract calls another contract. And it just so happens that Ethereum data is laid out this way. One transaction can actually create programmatically from within a smart contract more transactions, more contract calls underneath, but they're not visible in other places. You just always take a transaction and assume, okay, that's all there is. But no, there can be a tree, and I've seen some like on mainnet there's 65 calls like that. It's a big tree. And it happens that sometimes in there, well, there's important things happening. Like $1 million could be transferred in Ether, and you know, you could receive 75,000 DAI in there. And so the diffuse platform allows you to get down to that granularity, to search the internal transaction, which is not available elsewhere at all. And it gives you a lot of depth in terms of changes of storage, and you can actually build things using that. This represents a variable in your Solidity contract. And see, this is a change of that value. You can programmatically access that and see the changes. If you know this is the key for, I don't know, a certain variable in your contract, you know that value has changed within this call. Okay, so maybe that's a little deep for those who are newcomers. Hopefully this is useful, or at least for those who are more advanced. The different products we bring to the Ethereum ecosystem are the two following. First is search. So the search engine we built is purpose-built for blockchain, and indexes in real time anything happening on the chain. Those who are aware of the log events, right? You have a smart contract, you can emit a log, which is like printing a line in a log, right? Literally, and has specific fields. And for example, a token transfer will have a certain topic. It's going to say transfer with a from, a to, and the value, right? And then you have the from to in there that you can eventually search. Well, the blockchain nodes by default allow you to do some probabilistic search. It uses a Bloom filter, so it has false positives, so you can query the actual blockchain node and search for these things, but it's limited because blockchain nodes cannot be designed to hold 21, terabytes of data in RAM, which was, would be required to index all the things and search in all the dimensions. So that's why a solution like Diffuse comes in and allows you to search with no false positives. So you don't need retries and downloading blocks to verify that the data is actually in there, it was not a false positive. And search the whole blockchain history, so like from Genesis, for transfers of you to someone else or any sort of log with the different fields in there. We're not limiting the search to those that are indexed in the smart contract. We can search all of them, and the data bits also from up, I think, to 16 words, UN2 56 words. That you can search, even though it was not actually, marked as indexed in your smart contract. So, and there's a small language that we offer for you to be able to search either logs or calls. And when I say calls, I mean from to the transaction, the amount, the transaction, which contract was called, and all that. And this all searches internal transactions too, right? The scope of the search is always one internal transaction, one EVM call. Because that's the unit of change in the database, right? That's the most fundamental thing that happens in Ethereum. So search allows you to search backwards, forward, and listen to incoming events, both as a streaming and as a query. So And that's where the cursor comes in. You can do a streaming query. Let's say you load the past 50 transactions and then start from there and listen on to eternity, and you'll get updates. And that segment here going into eternity allows you to navigate reorganizations. So you'll have a small flag, undo, if the thing disappeared from the longest chain because of reorganization. And reorgs happen every day. Sometimes 1 block deep, 2 blocks deep, from time to time 3 blocks deep. And in chains like Ethereum Classic, we've seen 51 blocks deep, which is absurd. On mainnet, we have not seen these things, Ethereum mainnet, but you want to be aware of that, because $1 million could have been transfers, and a second later, well, it's not there anymore, because it's eventually consistent. So search allows you to have an extremely reliable stream of things, go backward, forward, and know what is happening on the chain. The next product I'm going to talk about, and Dennis is going to demo it and talk about a little bit more in depth, is the lifecycle endpoint. Lifecycle is, imagine you're on that, I was on ETHView at some point, and then, or another, Uniswap, and I sent a transaction, and I didn't know what was happening for like 15 seconds. I had no feedback, nothing. I wasn't aware that this transaction was acknowledged, or the application who sent the transaction, sent it. I wasn't aware of anything. So that's what happens on Ethereum, because you don't see what happens with the transaction before they get in a block on a node. And so we built a thing which is an instrumentation of the mempool, allows you to stream the mempool or to listen to a transaction's life cycle. But it allows you basically to say, this transaction, what's happening? And we're going to send you a simple stream of all the things that can happen and the state changes that happen. Like, let's say that the transaction is pending. It's been discovered in the mempool. It's propagated. So that's one thing. And then it could be mined into a block. But then it could be reorganized out, or it could be replaced by another transaction. If you send another transaction with a higher gas price and the same nonce, so nonce are ever increasing numbers, each transaction needs to have an increase in nonce, 1, 2, 3, monotonically incrementing. If you send another with the same nonce and the higher gas price, this one actually shadows the first one. Miners will want to take this one. And once they take this one in, they're paid higher price. That's why they'll do that. And this other transaction is actually going to be nullified, shadowed forever. It's never going to make it into a block because it's now invalid. Because the next transaction, once this is in, needs to have nonce plus 1. This one has an equal nonce. Okay, so all these things, we allow you to have one endpoint that will give you what's the current state of the network conditions, and so you can hook that to a small React, or whatever, Vue.js widget, so that users can have good feedback the fastest possible. Know if it's confirmed, it's forked out, so you hook it to a padlock if you have a level of certainty for something like that, or an icon, just to give a good experience to your users. And that's today, I think the best experience you can give your users is to track from the moment the transaction is sent and onwards with a transition. I don't want to take too much time. Do you have questions? And then I'll give the show to Dennis.
Hello, everyone. Thank you for joining the dfuse workshop. So I'm Dennis. I am a software engineer here at dfuse and also ambassador, because I come from a dapp development background. And so I'm here primarily to understand all developers' needs and what kind of features that you may have, and to tweak and recommend our APIs to your needs. So that's what I do best. So if you have any questions, feel free to jump in, ask me anytime during my presentation. So thank you, Alex, for presenting the holistic view. It's always nice to hear so much knowledge that he has. But let me just start off by giving you the kind of quick start guide as to how to get started with dfuse. So let me share my screen here. And okay, so I guess you can see it. So on dfuse, especially for Ethereum, there are two features, two core products of ours that are very unique. So that is search and lifecycle. So in order to get started with any of them, you would first want to go into dfuse.io and hop into our docs, which is where you can get a free account for our API. So here, if you go into the guides and go to working with your free account, and lucky enough, because our service is hosted, you might think, well, I might need to pay for just to experiment around. But keep in mind that for my day-to-day, usage, experimental testing and demos, I use a free account myself, and I've never run out of, quota. So if you are just hacking or starting or building your side project, this will be more than enough to not pay a cent. So head out to our docs or app.dfuse.io. That is where you will actually log in with GitHub or your email address, and you can actually get a API key here with a page like this. And next step would be getting a JWT token, which you can send over through authentication headers in all your requests. And that's basically it. All of our APIs use the same format. And so after you've done that, I would recommend everybody to go into the next step here, which is exploring ETH through Diffuse. So Diffuse queries, most of them we really value the powerful GraphQL APIs and GraphQL schema and GraphQL search and queries. So there's this graphical tool on all of our endpoints called GraphQL, which is what I have opened here. So this is a tool to let you craft the query and pass in variables and to see the data in real time within your browser without running any sort of service or backend or frontend or running any code at all. So here we have some examples that are already favorited for you. So for example, you can stream a search, and here you see that we're searching with our query language non-zero values in transfers. And you can see the results coming back. You can also get transaction by hash or stream the incoming blocks, things like that. This provides a very kind of easy and graphical view for you to really see what you can do and sort of craft your queries before you get started. So that would be the next step that I recommend everybody to check out. And then the step after that would be, well, you're ready to dive in. So we have, first off, a JavaScript library called client.js on our GitHub. And this is a client sort of very built-in SDK where you can, craft queries and do all the things handled for you. And here we have a quick start example to get you quickly started in Node.js. And then we also offer our APIs over gRPC in basically any language that you can think of. So we have examples here for Go and Python, but you can do PHP or C# or whatever you have. So if you go into this tutorial here with search with query language, you can see in this GIF format what that would look like. So essentially you have this search box where you type in your query. For example, you can search for non-zero values, or you can search for methods by name. You can search for account to or from. And when you click a run search, this app will actually just show you the responses that was received that was actually matching your search on Ethereum mainnet. And you can either do this with GraphQL query, so you can pass it the limit and paginate it by cursor, or you can just let them come in one at a time in a stream. So both of these things are available through GraphQL. And you can go through the entire example here. And essentially, it goes from helping you set up your key to the very end where you can have something graphical just like this in React that you can just build up upon. So if you have more usages on top of that, you can build on top of this repo. So that's search. And I wonder if anybody have any questions so far. Let me just check real quick. Will there be support for Rinkeby testnet? We have support for Robston, not yet for Rinkeby, but testnet, yes. Robston is what we are deployed on right now.
And the addresses, do they support ENS domains?
Not yet, but that is very, very, that is actually something I wanted to work on. And it's on the to-do list as I complete this hackathon. So if you really have some unique usages that you can see working, we could have that out very quickly. But not yet. But that is something that we see a lot of potential on. Is essentially just having part of our API as you can search by ENS domain or by the addresses even in the front end. But when the search results are returned back, we might parse it in our block explorer to show that as ENS domains. So so that's searching, and next would be lifecycle. So what does lifecycle look like in Ethereum? Let me just show you very quickly on ETHQ for that. So if you go on our block explorer and get the latest transactions, and say you go into the newest transaction, you can see that there's one confirmation so far, and there are a bunch of states that's within, in between the point where you first submit your transaction to when it's confirmed. So typically in Web3, JSON RPC, you don't have so much information as to, oh, is it pending? Has it been replaced? Or which state transaction has it just gone through? Because it could easily go from, say, in block back to pending, and then replace back to unknown. There's a ton of these state transitions that could happen, and we have a blog post for this actually on the 8 things that can happen to your Ethereum transaction, how to navigate them in your app. So this is what we saw as a big problem in Ethereum, and this is where API can solve. So here, how does this lifecycle work? So here we can actually run this query here just in GraphQL. And you can see that it comes in a subscription. So it's a constant stream. And as the state changes for your transaction based on your hash, the information that's returned actually changes. So you can see, you can have a real-time kind of reflection in your front end to say, okay, I sent the transaction, it's now pending, and then, oh, it's been replaced, or it's actually in block confirmed how many times. So this hasn't been done before, and in order to make front-end dApps more interactive and in order to have more sort of reflection to the user and better user experience, we think this is a very cool kind of API to use for that. And that, as far as I've seen, not many dApps have even considered having so much user interaction. So if you can think of some usage in this, that would be really neat, and we look forward to what you can come up with. So back to the examples, this is again something that can get you started from zero to tracking lifecycle in React graphically. And so that's this tutorial here. And it works through crafting the query and setting you up in React with hooks. And if you want even more examples, we have more samples over here. We can set up, in Go, in Python, in TypeScript, more advanced features. You can use Apollo, all kinds of stuff. And if you have any more kind of usages or libraries that you think or languages that you think you want to work in, you can always reach out to us, and we have a very capable team to adapt right to your needs. And so that's basically the tutorials. And if you want more in-depth information as to the core features, so search or lifecycle, you can go into our docs and go to the concepts here, and you can find transaction lifecycle, which would explain this whole thing for you. So what can happen to your transaction state. And if you want to find what you can actually search, you can go into core concepts under guides, and there's the guide for the search query language that you can use for ands and ors and nots, true or false terms that you can use. And specifically on Ethereum, we can search for, signer addresses, the method name or the method hash. We can search for nouns, to and from. All of these are listed here, and you can test that either in the tutorial repo that you build, or you can test that right on ETHQ here, just typing it in here. So for example, method transfer, and here you can get all the transfers search results back to you. And you can even craft your any types of queries with and or ors. So feel free to play with this a little bit more, and yeah, we would love to see what you can build. And does anybody have any questions for me or Alex that you can hop on the chat, or you can just turn on your